If you want to make a lot of money in software development, one of the best ways to do that is to build a SaaS, that's a software as a service business. Some of the largest companies in the world that you probably use every day are SaaS businesses and make millions, if not billions of dollars. Think of companies like Shopify, Salesforce, HubSpot, and tons of others. They make a massive amount of money, usually because they were able to build a scalable software that people actually wanted. Now, I won't tell you that's easy, but if you can do it successfully and you have a great idea, you are well on your way to making a ton of money in software development. With that said, how do you build a SaaS? Well, first, you need a good idea, which I'll leave to you. Second, you need software, and you need to build the software in a way such that it's scalable, you're getting the correct analytics, and you're able to deliver value to your customers. So in this video, I'm going to share with you one of the best stacks to go with if you're looking to build a SaaS as fast as possible. Now, keep in mind, there are so many different technologies, millions of ways to go about building software. This stack I'm going to share with you is something that I use personally, that I've had a lot of success with, and that I know many other people are using that are raising millions of dollars and building SaaS companies right now. As you get more complicated, your tech stack may change, but if you're looking to get up and running off the ground as fast as possible, this is something you probably want to consider. With that said, let's dive in and let me share with you the ultimate SaaS toolkit. So let me start by mentioning that I am no SaaS god. I do not hold all of the answers, so take what I say with a grain of salt and obviously do your own research. There's so many different ways to build a successful company, so many different technology stacks you can use, and just because I recommend one doesn't necessarily mean it's the best. It's just from my personal experience and what I've heard from a lot of other people in this space. Regardless, for a lot of these services or whatever you're purchasing, you're going to need to buy it from somewhere. Now, in that case, I'd recommend you check out the sponsor of this video, which is Linode/Akamai. Now, it was formerly called Linode. The new name is kind of Akamai, but they're kind of mixing and matching. So Akamai, Linode, pretty much the same thing. Anyways, I've worked with them for over 4 years. They're personally what I use for all of my cloud service needs. I have Kubernetes clusters with them, virtual private servers, storage volumes, got Terraform stuff going. I got all kinds of stuff with them. I use databases on Linode. I have my domains hosted there. Literally everything is with them because they're so easy. They're so nice to use. It's super fast, and they have a real support team that I've actually reached out to many times that are super helpful. So I don't have to wait in line. I don't have to talk to robots. I just reach out and talk to a legitimate human being, which is a massive benefit. Now, Linode has pretty much everything you can imagine, from storage volumes, storage buckets. They can do serverless architecture. They have one-click installs for all the databases you might want. And since they're partnered with me, you guys can get a $100 free 60-day credit by clicking the link in the description and signing up for a new account. As I go through the different services in this video, pretty much every one of them that I mentioned is available through Linode, so feel free to check that out and use it for free with that credit that I just mentioned. So the first thing you'll likely consider when you're building your SaaS business is, what is your backend going to be? Specifically, what type of architecture are you going to have? Now, I like to recommend that people go with a serverless architecture. This is great because it means you don't really need to worry about the infrastructure that your code is running on. You simply worry about writing correct and scalable code, and then you allow cloud providers like Linode, Google, Amazon, Microsoft, etc. to handle that deployment and the orchestration for you. Now, with a serverless architecture, that means that your different cloud functions, which we'll get into in a second, are going to automatically scale up and down, and you're only going to pay for what you use for. Now, there are some disadvantages to this, which I'll get into later on, but typically if you're trying to get up and running as fast as possible, go with a serverless architecture where you're working in some type of environment like Node.js, Go, or Python. You can write something known as cloud functions. These cloud functions can respond to different events. You can schedule them to run. You can make them run when things change in a database or a storage bucket, and it's very useful for writing a backend that's very scalable and easily maintainable because of the small size of the functions that you're writing. Now, a practical example of something that would use serverless architecture is something like YouTube to MP3, or any of those converters you see online. Typically, what they'll have is a cloud function running on the back end, and this cloud function will duplicate itself and expand or scale as more demand is required, and it will shrink down and stop being ran when no one's using the service. That means if 100 people go to YouTube to MP3, it can handle that demand by just spinning up more instances of the cloud function, so it can do this in parallel, and if no one's using it, it just tears all of them down, so you are not paying for usage that you don't have. Lastly, the major advantage to cloud functions and serverless architecture is that deployment is typically very simple and it's handled for you by the cloud provider. So you don't need to worry about setting up an automated pipeline and all of this crazy stuff for packaging and deploying your code. You simply run a few commands, make sure your code is set up in the correct manner where there's all kinds of guide for, and you can just deploy your code to whatever the infrastructure is and not worry about where your code is running, just worrying about writing the code itself. All right, so now that we've talked about our backend architecture, let's talk about storage, specifically storage for things like videos, files, images, large pieces of data that you're not going to store in a traditional database. Now, you could store this on, say, a hard drive, right? You could store this on some remote server. The issue with doing that is you don't really get a lot of flexibility, and as soon as you reach the maximum storage capacity, it's very difficult to scale that up and to increase it. So imagine you have like a 2 terabyte hard drive, right? You're going to pay for that hard drive, maybe it's $70, $100, whatever it costs. Now, even if you're not using all of those 2 terabytes, you're still paying for the entire hard drive, and as soon as you fill it, you now need to add another one. Not very flexible, a lot of issues with that. You're going to have some redundancy concerns. What if the hard drive fails? So instead, you want to use something like a storage bucket. Now, a storage bucket is a redundant, globally accessible, and essentially infinite size bucket where you can store information. It's provided by companies like Linode, Amazon, Microsoft, all of the large cloud providers have it. And what you can do is only pay for what you use and continue to increase the size of the bucket as your data needs increase, right? So if I only have one user, I pay a few cents. If I have millions of users, I pay tens, maybe hundreds of thousands of dollars for my storage bucket. But again, the point with the storage bucket, it's backed up, it's redundant, it's in multiple different locations. You can access it from anywhere around the world. You have some URL that just links to that file or to that media, and it has all kinds of permissions and typically will hook in with your backend architecture. That means you could actually check to see if something changed in your storage bucket, and if it changed, you could trigger a cloud function to run, for example. So you can look into that more. I won't kind of make a whole video about storage buckets here, but I'd highly recommend that you use that for all of your user-generated content, especially if it's going to be very large files. Anyways, that is storage. Let's move on. All right, so now that we've talked about storage, let's get into databases. Now, databases and storage are different, right? Storage is going to be those larger files where you have typically videos, photos, etc. And your database is going to be for that more granular, smaller information. Think usernames, passwords, comments, likes, small relations, tracking stats, okay? That's the type of stuff you're going to put in a database. Now, for a database, you have really one main big decision to make, and that is, do you want to go with a relational database or a non-relational database? Now, both of them have pros and cons, and I could make probably an entire series talking about this, but what I recommend for most SaaS businesses is to go with a non-relational database, something like MongoDB, Firestore, something that is NoSQL, okay? Now, people will have a lot of issues with this. There may be many people in the comments that say, no, you should go with a SQL database. The reason why I'm recommending this is that a NoSQL database is typically easier to scale horizontally, meaning you can actually shard it out onto multiple different machines. If you go look at something like MongoDB, you can see how they do all of their scaling there. And it's good when you're working really quickly and when your data schema is changing very fast and frequently. So that means that maybe you have 4 columns right now or 4 fields in your data, but in a week you're going to have 20 fields or 20 columns. In that case, it's going to be a lot easier for you to work with an unstructured database, which is a NoSQL database, rather than working with a SQL database or a structured database. Now, I will say the advantage of using a structured database is your data is much more consistent, it's cleaner, you have a lot less issues in terms of checking the integrity of that data and dealing with it in the future, and you can run much more complex queries much faster and more efficiently. However, NoSQL, again, in a very dynamic, fast-changing environment, is typically preferred, and that's usually what I like to use, especially when it comes to setup and deployment. NoSQL databases are going to be easier than your SQL databases. The only time I really recommend the SQL database is when you kind of know exactly what you're doing. You're going to have a more mature data structure. You have experience with databases. You understand SQL. You can write those more complex queries. For most people that aren't database engineers or backend developers, NoSQL will probably be your go-to. Now, I'd love to hear your thoughts on that in the comments, by the way, so let me know down below. Typically, I recommend you just go with something like MongoDB or Firebase. That's what I have experience using. If you do want to go with a SQL database, you have a bunch of options, Postgres, MySQL, all kinds of other add-ons and extensions you can use. Again, don't want to get too into the weeds here, but something you should do a bit of research on and look into, SQL or NoSQL. All right, so now we move on to talk about the front end. Now, before I get into any specific tech stacks or what I'd recommend, I'll say that for the front end, really the important part is that it loads really quickly, it looks good, and that it's responsive. Whenever you're building a SaaS, those are the three main things you're going to want. That's just immediately going to make your company look professional and give a great user experience. If your page speeds or your load speeds, are really slow, that's going to immediately turn people off. I know for me personally, if I ever go to a website and it takes more than 2 or 3 seconds to load, I usually don't continue navigating to that website, or I only go there if I really need to be in that place. There's actually a lot of stats online that kind of talk about user retention and page speeds, but you want to make sure whatever you're doing, you load it quickly and you keep that in mind, right? Speed is very, very important. Same with responsiveness. If I press a button and I don't get any feedback or I don't know what's happening, that's really going to turn me off as a user. So you want to make sure that everything is responsive, it's clean, it's simple to use. That's a lot of user experience and UI stuff. Don't need to dive into that, but that's the main consideration here. So whatever you pick for your front end, make sure you hit those different boxes. With that said, what I'd recommend to create kind of an efficient front end, and what's popular now, is to use server-side rendering. Now, server-side rendering means that a lot of the load is being handled by the server, so it's actually kind of generating the entire completed HTML document and then sending that to the client, where very minimal work is done to render that page. Now, that's the opposite of what will typically happen with a dynamically loaded website, where what you're doing is downloading the HTML from the server, and then you're downloading all of the additional resources like the JavaScript, the CSS, and then your client is compiling that all together and rendering the website for you. So server-side rendering means you're taking a lot of the load that's typically done by your client and you're putting that onto the server. That way you can load the page faster immediately once it hits your browser. Now, there's a lot more complexity to that. You guys can kind of add to it in the comments or let me know what you think, but I'd recommend you go with server-side rendering. And if you wanted to do that, you could use something like Next.js and React, or I believe the other alternative is something like Nuxt.js, Nuxt.js, and Vue.js. There's a bunch of other front-end frameworks, obviously, but those are the two popular ones. Personally, I use Next.js and React. So now let's move on to some of the more complex but very important things you want to consider as your application or your SaaS grows. First, continuous integration. Now, this really refers to continually integrating changes into your repository or into your code base and ensuring that any change that you make is stable and working, so that you have a high degree of confidence that the code on your main or master branch is always stable and up to date. Now, this is a lot easier said than done, and I am grossly simplifying what needs to be done for this, but at a minimum, you're going to want to be writing tests for all of the important aspects of your code. So for me personally, if I'm trying to go quickly, I make sure I test all of my backend. So every single backend function I have has a set of unit tests, so I know that all of those backend functions are working as they should be. Then I will set up some minimal integration tests, so I know that my front end calling my backend is working properly, and any systems that are interconnected are kind of communicating in the correct way. Going a step further, you could set up end-to-end tests where you're testing the application really from a user's perspective and going through everything from the front end to the back end to making profiles to signing up, etc. That's a lot more work, not something I typically do at the beginning stage, but you want to set up all of this automated testing and you want to write in kind of a test-driven development way. Now, a lot of people have different opinions on this. I'm not going to say that I'm the best at testing code in the world, but I definitely try to do that, at least for the integral and data kind of aspects of my application. So I know that at minimum, the entire backend is working, and then I can deal with the front end tests, which are a bit more annoying to write. So you want to write all of these tests and then set up automations so that they're automatically going to be ran before you make any change or commit anything to your main or master branch. The simplest way to do this is to use a tool like GitHub Actions. This can automatically invoke testing scripts that will run against your code when you make a pull request. You could go a bit more complicated and get into things like GitLab or Jenkins. Not going to talk about those too much in this video. At minimum though, have some automated testing. And if you're getting a bit more complex, you may actually want to build the entire application, push that to some kind of environment and have it be tested on, say, multiple different devices or in multiple different environments. All right, moving on very closely to continuous integration, we have continuous deployment. Now, this means that anytime you are making a change that is going to be stable and should be deployed to something like the main or master branch, it's automatically going to be deployed, and all of the environments that need to be configured will be kind of done automatically, right? So let's imagine, again, you kind of have a pull request, maybe you merge that to the main branch, maybe you have some production branch, and all of a sudden, you fork off of the main branch to the production branch, and you're now ready to push something into production. Well, Rather than having to do this manually every single time, you'd want to set up a continuous deployment, so some kind of automation where it would automatically say push your cloud functions or update your cloud functions. It would automatically make a new build and upload that to the App Store or the Google Play Store, or push it to a website or whatever it is that you're doing. That's really what's referred to here in continuous deployment, that you are continually deploying changes as they are made. Now that could be to production, that could be to a staging environment, that could be to a dev environment where you have some maybe public URL that people can use. Doesn't matter what you're doing, you want to set up all of these automations. Now, it's hard for me to get into a ton of detail here without making this video super long. If you want more on this topic, then let me know in the comments down below. All right, so we've gone through some of the main concepts here, but I just want to mention that as you start scaling and getting bigger and bigger, and maybe your team grows and you're into some more complex and advanced tools or use cases, you may want to consider looking at things like Kubernetes and Nomad and slightly changing or adding different architecture that's not purely serverless. So for example, serverless architecture is really good. However, when you get into long-running tasks, high computation, and you're doing things like image processing, machine learning, model training, whatever it may be, where there's a lot of compute power required, that's probably not going to lend itself well to serverless. Instead, you're going to be setting up your own environments, your own type of deployments, your own configurations, which are much more complicated, but are definitely worth it when you need that type of environment and that type of compute power. So really, in summary here, I just want to mention that once you start getting into bigger use cases, you have multiple microservices communicating with each other, you have long-running tasks, you're doing a lot of compute, you have some back-end heavy operations you need to perform, you may want to stray away from regular cloud functions and move into something like Kubernetes, Nomad, Docker, all of those things that are really helpful for setting up those more complex environments that need some more fine-grained control. All right, so now we have the core building blocks for our SaaS application. The one thing we are missing is analytics, right? We need data, we need user data, we need backend data, we need performance data. We need all of this stuff to make decisions as a business and to understand where our software is lacking, where we can improve, and yeah, how we can get better, right? So whether that's Google Analytics, whether that's more advanced platforms or tools, I won't get into those in this video. You want to make sure that you are tracking things like crashes, bug reports, page load speeds, backend function calls, anything that has high latency. That's all of the stuff that you're going to get into once your SaaS is successful. You have some users, people are actually on the website or application. Now you're going to start analyzing all of that data and seeing where you can improve. Now, the type of analytics you're going to use is really going to vary depending on the project that you're using. I can get away with using something like Google Analytics. For some of you, you may need some more advanced platforms. You might get into something like BigQuery, where you're now using Google Analytics, but in a much more advanced way. All kinds of tools here. I don't really feel qualified to talk about them, so I'll omit mentioning any specific ones. And with that said, I think I'm going to wrap up the video here. Now, I know this wasn't extremely detailed or specific, but I wanted to give you a high-level overview of the different tools and technologies you will need if you are building a SaaS. Hopefully, this got the wheels turning, got you thinking about different things and considering different options. Obviously, you need to do your research, take everything I said with a grain of salt, and pick the best stack and language for you and for the application you're building. With that said, thanks very much for watching. Leave a like if you enjoyed, subscribe to the channel, and I will see you in the next one.